welcome. Today is part 9 of the chapter binomial theorem for preparation for the examination JEE Main, Advanced and for different state level joint entrance examination. First problem today is problem number 42, and it is the coefficient of x to the power 15 in sigma r is equal to 0 to 20 1 plus x to the power r. Options 21C16, 20C16, 21C15 and 20C15. Problem is straightforward. A series is given. It has 21 terms. It is a first term is 1 plus x to the power 0, that is 1. Second term is 1 plus x to the power 1. Then 1 plus x square. Then 1 plus x whole cube up to 1 plus x to the power 20. In that expansion, to find coefficient of x to the power 15. So the series is 1 plus x to the power 0 plus 1 plus x to the power 1, 1 plus x to the power 20. Clearly, it is in GP. First term is 1 and common ratio is 1 plus x. Adding them, it will be 1 plus x to the power next third term 21 minus first term divided by common ratio minus 1. That is, it is equal to 1 plus x to the power 21 minus 1 by x. Now, from here, we have to find coefficient of x to the power 15. Actually, it is 1 plus x to the power 21 by x minus 1 by x. Second term must not contain x to the power 15. So we have to find x to the power 15 coefficient of that from here. So coefficient of x to the power 15 is equal to. So in this one, coefficient of x to the power 16 will give you the coefficient of x to the power 15. Coefficient of x to the power 16 from here, because there is x in denominator, that will give you the coefficient of x to the power 15, and it is equal to 21 coefficient of x to the power 16. That's all. So our answer is this. So first option is correct. Now problem number 43, and the problem is the sum of terms which are integers of that binomial 3 to the power half plus 2 to the power 1 by 3 whole to the power 10 is. So we have to find, anyway, this is a binomial. It must have 11 terms. We have to find the sum of the terms which are integers, not fraction, integers. Now, you see, first term of this binomial is 3 to the power half whole to the power 10. That is 3 to the power 5, which is an integer. So we have to count it. After that, which are integers, we have to find first. The power is 1 by 2 and 1 by 3. Its LCM of the denominators 2 and 3, its LCM is 6. Clearly, after 6 terms, it will contain integers. First integral term is first term, which is 3 to the power 5. So this one is there. After 6 terms, it will be integer. So 7th term will contain integer. After that, 13th term will be integer, but it has no 13th term. So required expression is T1 plus T7. T1 is nothing but that 3 to the power 5. Oh, sorry. Options not yet given. Options are 36 plus 5 into 10 C6, then 36 plus 10 C6, 36 into 10 C6 plus 3 to the power 5. Next one is 30 into 10 C6 plus 3 to the power 5. So these are the options. So just now I discussed you that its first term and 7th term will contain integral values. The first term is simply 3 to the power 5, just now we have seen. 7th term will be 10 C6 into 3 to the power half whole to the power 4 into 2 to the power 1 by 3 whole to the power 6. So that it is equal to 3 to the power 5 plus 10 C6. This is 3 to the power 2, that is 9. 3 to the power 2, and it is 2 to the power 2. So that this is 36 into 10 C6 plus 3 to the power 5. So 36 into 10 C6 plus 3 to the power 5. This is our correct option. So option C is correct. Next. Problem number 44. Now problem number 44 is sigma r is equal to 0 to 5, 10 C r minus sigma r is equal to 5 to 10, 10 CR. The value of that options 2 into 10 C5 0 to the power n minus 1 10 C5. These are the options. Now to find, there are actually 6 terms, there is another 6 terms. We have to find their sum. After expanding, this is equal to 10C0 first term plus 10C1 plus 10C2 plus 10C3 plus 10C4 plus 10C5 minus 10C5 plus 10C6 plus 10C7 plus 10C8 plus 10C9 plus 10C10. So this is equal to, first one is 10C0 plus 10C1 plus 10C2 intact minus this is actually 10C5. This can be written as 10C, 10 minus 5, that is same thing, 10C5. Then this is 10C4 plus 10C3 plus 10C2 plus 10C1 plus 10C, last term is 10C0. Now you see 10C0 and this minus 10C0, they will be cancelled. This is 10C1 minus 10C1, pairwise they will be cancelled. 10C2, 10C2. So 0 answer. So option B is correct. টুক টুক করে যাচ্ছে শুধু। Next, problem number 45. If 3 to the power 9 plus into 2 to the power 27 is divided by 25, the remainder is option 24, 14, 21 and 7. This is the number, big number. So when this is divided by 25, what is the remainder? And these are the options. Now this can be written as 2739. So 3 to the power 9 into, it is 2 cube, that is 8, that also to the power 9. So that it is equal to 8 into 3, 24 whole to the power 9. Can be written as 25 minus 1 whole to the power 9. So this is equal to 25 to the power 9, then minus 9c1, 25 to the power 8, then plus 9c2 into 25 to the power 7, minus this way 9c9, 9c8 into 25 to the power 1, and finally minus 1. Now you see, all terms up to this are divisible by 25, excepting this one. So when whole thing is divided by 25, the remainder is minus 1, this one. But the remainder cannot be negative. So the remainder must be, we have to add 25 with it. 24 is the remainder. So first option is correct. Next. Problem number 46. The sum of 1 plus half NC1 plus 1 by 3 NC2, this way up to 1 upon n plus 1 NCN. The value of this sum, how much? Option 2 to the power n plus 1 minus 1 by n plus 1. First option. 3 into 2 to the power n minus 1 by 2n. 2 to the power n plus 1 by n plus 1. And last option is 2 to the power n plus 1 by 2n. Here we have to simply, nothing is given, we have to find sum of that. We know that 1 plus x to the power n, that binomial is 1 plus nc1 into x plus nc2 into x square up to ncn into x to the power n, that is equal to 1 plus x to the power n. This binomial is this one. This is a formula. So by putting x is equal to say 5 or x is equal to 1 on both sides, both sides will be same. Similarly, but if we differentiate this and differentiate that, thing will be same. Here, as because in denominator, in answer, in denominator, the numbers are 1 by 1, 2, 3, etc. running serial. So integrate both sides with respect to x. So integrating both sides with respect to x, 1 plus nc1x nc2x square up to ncn x to the power n plus 1 dx from 0 to 1. So we have to integrate this from 0 to 1. Dx. That is, this is actually integration of 1 is x plus nc1 x square by 2 plus nc2 x cubed by 3 ncn is nothing but 1 x to the power, oh this is n, x to the power n, x to the power n plus 1 by n plus 1 limits from 0 to 1 is equal to integrating that 1 plus x to the power n plus 1 by n plus 1 limit from 0 to 1. Putting x is equal to 1, it is 1 plus nc1 by 2 plus nc2 by 3 plus ncn by n plus 1, and the lower limit, putting x is equal to 0, lower limit, all terms will vanish. So this is equal to that, is equal to, here it is 2 to the power, putting x is equal to 1, 2 to the power n plus 1 by n plus 1 minus, putting x is equal to 0, it is 1 upon n plus 1. So for answer, 1 plus nc1 by 2, nc2 by 3, and so on. This is equal to 2 to the power n plus 1 minus 1 by n plus 1. This is our answer. So first option is correct. Option A is correct. One trick, mind that, if in a series like that, if in denominator there are running serial, means 1, then 2, then 3 in denominator, always you have to integrate both sides and putting suitable limit. And if that is the running serial in numerator, say 1 into this plus 2 into something, then 3 into something, etc., you differentiate both sides and put suitable values of x. That will give you answer. So okay, today is up to this, and I request you to, if you feel that it is helpful for you, so please subscribe my channel, like and share. Thank you.